Welcome back to the Contractor School. Remember, take good notes. We're in the section for motors still. Okay, and this is another question. There's going to be a ton of these questions. Very simple. Just use the table, knock them out. Okay, I'm going to probably just pick up the pace just a little bit, see if we can get through a couple of questions in this particular section of our lecture. Calculate the minimum size branch circuit conductor. So we're still talking about the branch circuit conductors. We're not talking about overcurrent protection yet. We should get to one of those. I'll try to find one here in this material and make sure we go through overcurrent protection as well, because we want to make sure we cover that. It's not always going to ask for the for the branch circuit conductors. A lot of times it's the overcurrent protection. So let's just make sure we get this one down. We'll do one more example here on branch circuit conductors or feeders. I'd like to do multiple motors as well if we can get there. Okay, so calculate the minimum size branch circuit conductors for a single motor given the following conditions: 480 volt, 3-phase. Let's write all this detail in our notes so that we can get moving on this thing here. So in the details on this one, right, is it's a motor, right? Motor question, right? It's 480 volts. That's obviously 3-phase. Let's just write that in there anyway, right? And we know it's a squirrel cage. So let's go and put design B there. Squirrel cage, right? And then it's a 20 horsepower. Okay. The nameplate is 21. The nameplate is 21.0 amps. That's interesting, because notice I got nameplate and I also got horsepower. So let's be careful here. And then the conductors, right? The conductors are rated at 60 degrees C, but the terminals are rated at 75 degrees C. Okay, well, which column are we going to use? The terminals. I said to default to terminals earlier, didn't I? Default to terminals. Well, not in this case, because it's the terminals or the insulation, whichever is lower rated. So aren't these ones lower rated? Right, the conductors connected to the terminals are the lowest rated. They're the weakest link in the chain, you might say. So this would be the column we'd use, right? We wouldn't use this one. Let's put an X by that one. We'd want to use this one in terms of the column. So that's the most interesting thing in this particular question for me. The other thing is, since we're talking about the branch circuit conductors, right? Since we're talking about, let's go ahead and write that, right? Since we're looking for the branch circuit conductors, right? Right, that's our question, right? Do we use the nameplate, or do we use the horsepower and get it from the tape, get our FLC from the tables, right? I'm going to put an X here because the answer to that is, of course, no. We don't use the nameplate. We use the horsepower and the tables to get our FLC. So let's start there. The FLC for this particular motor. And see where we're at here on this code. Yep, we're on the wrong table, right? So let's move on to 430.250, and that's our 3-phase table, right? So let's just head on over there together. It takes me a little longer to get there because I don't have a tab on a computer, right? And then we're going to go down to the column for 460. They gave you 480, right, just to confuse you. There's your 460 column. And you follow it on down till you see 20 horse, right here, right? So once again, 460 and 20 horse line up together. Look there in the corner, I see 27 amperes. 27 amperes, right? I'm right here, right, with this 460 column and 20 horsepower, 27 amperes. So if the FLC is 27 amps, let's go ahead and put that in our notes. I want to make sure we get all the detail here and make sure that we got our notes correct on this. Okay, if the FLC for step number 1 is 27 amps, right? Let's go ahead and put that FLC from table 250, not 250, 430.250, right? That's our 3-phase table, okay? and that gave us 27 amps. Okay, now remember, don't forget, write a note, get a tattoo, whatever you need to do, right? We need to multiply by 125%. That is a minimum, right? Times 1.25. We have got to do this or we're going to get this thing wrong, right? We've got to multiply by 125%. Once we do that, let's go and pull out our calculator, make sure we get the numbers right. 27 times 1.25 equals 33.75, right? So we multiply that out, and let's put it in our notes, 33.75 amperes, right? Well, we're trying to size the conductors, So we've written this like 15 times now, right? We got to take this on over to table, right? 310.15, right? B16 and all that stuff, right? And when we do that, we would size a number 8. But let's go double check, make sure that we got it right. Okay, so table, once again, 310.15 B16. So let's go there together. I'm sure you guys will get there in a hurry. I gotta flip this thing. That's not it. That one's the one we don't want. And there we are. Okay, so now that we're at the right table, and like I said, if you got a tab, you probably already beat me there, right? Remember the question said that the conductor rating was 60 and the terminals were 75. But don't we need to use this one here? I'm going to highlight it, right? And don't we need to use this one here, right? And so notice the fluff they give you, right? This is meant to trick you. This is meant to trick you. We don't use those. We use a 60-degree column and we use the 20 horsepower, right? You got to be careful here. They give you information that you don't need to see if they can suck you down the wrong road down there and get the answers wrong. You got to know the theory and the math. The theory and the math are required in this case. So now that we're at the right table, we use the first column, right? 60 degrees C, right? Like if it's NM, like let's say it's a residential application, right? Or UF or TW or NM, like we wrote right there before. And we go down to 33, right? We go down to 33. I see 40, right? So, if we're in the correct column and we got the right row, we just line it up here and the 40 amps lines up with a number 8. And that is knocked out of the park. Not very difficult, okay? But there are some tricks to it, right? In that they give you a nameplate that you don't use, and then they go and give you terminations rate at 75 degrees, and you don't use that either. So, this kind of stuff in here was just meant to kind of confuse you, okay? So once again, let's go ahead and put here that we got a number. We've got to size up, right? Isn't that what it showed? 40 amps, right? Yeah, 40 amps. So we got to size up to 40 amps, and we get a number 8 Og conductor, right? Got to size up to 40, right? We got to size up, and we get an 8 Og conductor. Okay, so pretty easy question, as long as you don't mess it up, right? Okay, so let's go to another one, a very similar type question, but I want to make sure that we get this in our notes on just a different type breaker. Pretty simple, but instead of sizing, notice the last couple of questions, right? This has been branch circuit conductors. I think this one was equipment grounds, right? A little different. That was a little different, right? Equipment grounds. It was a little bit of a curveball. But this one here was conductors again, right? So that one was conductors. This one was a conductor. That one was a branch circuit conductor. This one here was branch circuit conductors, right? So that's a lot of what they're going to ask. However, this next question is not asking for branch circuit conductors. It's asking for what? Overcurrent protection. Overcurrent protection. Calculate the maximum standard rating. Do not exceed the calculated value. That's kind of interesting. Of a motor branch circuit, short circuit, or ground fault protected device given the following conditions. Okay, so let's go and write this one in our notes as well. And if you have to go ahead and start a new page, if you must, I'm going to go ahead and start a clean page here on the board. Make sure you take good notes now, okay? So in this case, the motor right is 480 volts. It is a three-phase motor, right? It's 30 horsepower, right? It's design B. And the protective device. Now here's the interesting part, right? And we haven't really done too much of using this tool. We used it one time. It's using an inverse time circuit breaker. Inverse time breaker. Okay. Now that we're gonna need a couple tables here, right? So let's go ahead and put this in our notes here. First of all, we need that FLC. We always got to get that FLC, okay? But when we're sizing the overcurrent protection, we don't use the multiplier 125%. We got to use the table, right? So the first step here is to get our FLC. We get that from table. We've done this a bunch of times now. 430, 250 since it's three phase, right? 430, 250. And let's go ahead and do that first. See where we're at. Wrong table again, of course. That's okay. Let's just move on over. You guys can just flip there. 430, 250. And I'm close, right? Okay, passed it. Where did it go? There it is. Okay, and in this case, we're in the 480 column again, right? Right here. And in this case, it's 30 horse, right? There's no FLC given, right? There's no FLC given. Since there's no FLC given, even though we're doing the overcurrent protection, since there's no nameplate given, we have to use the FLC. We have to get the FLC from the tables, right? But we should have been given in this question, right? In this question, if you notice, it's not given. We should have the nameplate here, but there's no nameplate, right? So they're kind of trying to confuse us, right? Because for overcurrent protection, we should be using the nameplate, but it's not given. So we have to use the horsepower. It's kind of a poor question in a sense because they should give it, right? But they're not in this case. So we do need to use the tables because that's what's given in the question. Slide down, in this case, 30 horsepower, way over here. So if I highlight it correctly, right, the 460, 30 horse in the corner there, bottom corner of the blue section there, I see a 40 amperes. 40 amperes, pretty straightforward stuff, right? 40 amperes, right down in here. Let me highlight it one more time. 40 amperes for the 30 horsepower motor, okay? So in our notepad, right, we got 40 amps. Now, the multiplier is not, I'm going to put here, what the heck, not 125%, right? Why? Because that's for the conductors, right? That's for the conductors. No, 100 times no, right? We need to use a table in this case. A table, and we've been there once before, and this is 430, 52, right? Why? Because we're talking about overcurrent protection. Write that in your notes, right? Write that in your notes. Overcurrent protection, we need this table right here. That's step number 2, right? Step number 1 is the FLC. Step number 2 is to get our multiplier from the table. Get our multiplier from the table. Okay, so let's go ahead and do that. Now it says here that we're using inverse time circuit breaker, right? So I mean that's key here. I mean if we don't see that, then we're doomed. We can't solve it. Okay, so we just need to pull up our code book here and back up a little bit to the proper table. Okay, and you guys could just flip there. I believe their standard tabs do have a tab on this one. Okay. And once again, they could use any column, non-time delay. This one happens to be design B. So the design B is down here. Other than design B would be here. But like I said, just be careful with the type of motor. We used single phase before as well. They could ask wound rotor and synchronous, I suppose. Right, this one is design B, so that's the correct row. And then the correct column, it said is inverse time breaker. Right, so isn't it this far right column? Right, because we've got non-time delay fuse, dual element fuses. Both of those are fuses, and both of these ones over here are breakers, right? So we've got the fuses on this side, breakers on this side, right? So inverse time circuit breaker is right there, right? Lined up with a design B here, and I see a multiplier of 250%, right? Pretty easy stuff. Pretty easy. I think we're getting good at this now. I think we're getting good. So let's go ahead and put it in our notes. Times 2.5, right? We'll just put it right in there. Isn't that 250%? We're getting good at this math, aren't we? Sure. And let's multiply that. We could probably do it in our head, but let's don't do that because we don't want to make a mistake. We could verify, with the calculator, and I think that probably makes sense. 40 times 2.5, and sure enough, it's 100. Okay, so 100 amps, and of course that straight away is a standard, isn't it? Right? But this value is going to put down that's the answer, right? But you should verify. We're not going to turn there this time with table. Right, verify the standard. Verify the standard with table, what is it now? 240.6. Very good. Very good. For those of you who are paying attention and following along, praise the Lord. Okay, so 100 amps, correct on that one. Okay, let's see if we can't knock off a couple more. We're just knocking things out. Doing pretty good here. That one was on overcurrent protection. There's just so many questions that they can ask, on these particular motor questions, and there are a lot of them on the exam. Okay, so let's just move down to the next one I have here queued up. It's not very different. It's actually very the same. Let's see if there's one that's a little different. Yeah, this one's different. So moving on to a little bit different, right? This one's a generator. Motor questions, I'm guaranteed they're going to ask like this one here. Let's just breeze through it, right? This one's 230, not 480. It's 7.5 horsepower, not 30, right? They give you both the horsepower and the nameplate rating, so watch out what you're doing here. Make sure that you use the horsepower, not the nameplate, because you're talking about the branch circuit conductors, termination 75 to VC. So just careful with what you don't need. In this case, you don't need that. You don't need the nameplate rating. You need the horsepower, right? So just be careful. Be careful. Different question, same deal, same procedure. Chicken feed, right? This is not tough that we can do this. Okay. So, and you're going to see all these notes in the software as you study this material down the road. This will be in your build, and you can definitely get that from the school. Okay. So, if a motorized generator is operating at 50 volts, what would be the maximum overcurrent device to protect the equipment, given the unit has an FLC output rating of 100 amps? Interesting. Well, you can almost guess 125, right? And then everyone's going to come over here and guess this, and that would be, guess what? Wrong, right? Because we don't guess. We don't guess. We have to look it up. So this is for generators, a little bit different. Okay. 445.12. Let's go ahead and go there. 445.12C. Okay, let's go there in our code books. We're jumping out of motor here. It's a type of motor, right? Kind of. It's a generator, and but it's motorized, right? And then C down here, it's kind of an interesting little question here because a lot of people are going to jump over here and get the 125% from this other section over here or whatever. But this one here, yeah, I bet you this is where it's at. Yeah, see 115 on over here. You can get it wrong, right? And passive conductors. Careful now. Careful, because we're talking about overcurrent protection. Overcurrent protection, not the branch circuit conductors. And the details were that it was 65 volts or less. Like let's say 60 volts or 55 volts or 50 volts or less. then it needs to be protected at 150%. So I'll give you a second to highlight that. Once again, we're at 445.12 C. That's on my page, by the way. Let me just check here. That's on my page 330. Page 330 on my NEC 2017. And article reference 445.12 C gives us 150%. 150%. So let's go ahead and put that down in our notes. Right? Put a little line here. Gotten out of motors there for a minute. 445.12 C, right? And this is, of course, we talked about a generator, right? A generator, and a generator operating. Let's go ahead and put 65 volts, right? Right, and it has an FLC. There it is. It has an FLC. Let's write this down of 100 amps. The question is, right? The question is, put a question mark there. What's the over current protective device, the OCP, right? In amps. Well, shouldn't we just get our 100 amps, right, from our FLC? Right, this is our FLC here, and multiply it by 1.5, right? That's our 150% that we just looked up, right? Multiply that out. That one we can definitely do in our head, right? 100 amps times 1.5 gives us 150 amperes, right? So correct answer, 150. Make sure you put a box around that thing. 150 amps in your notes for that generator. Very important, okay, that we get our notes correct, okay? So, you know, there's, like I said, a ton of different types of questions they could ask. Single phase, three phase. Let's just take a quick look at the next one. Maybe we'll knock out a couple more here. Let's see if there's anything unusual about this one. Calculate the maximum standard rating not to exceed the calculated value of a motorized branch circuit ground fault predictor device given the following conditions. 230, three phase. I don't see anything unusual here. The horsepower is given. And oh, look at that, instantaneous trip breaker. That's interesting. Well, we looked that up earlier. That was a multiplier of 8, right? 800%, 8. That's going to be a big old monster. Okay, that's going to be a big multiplier, right? A big multiplier. Okay, and so let's just take a look at the math real quick. We don't have to put it in our notes this time necessarily, but we get our FLC 28 amps, right? And that's what we get from 430 to 250. And then get our multiplier of 800% from table 430.52, right? And so look at this thing here. 28 times 8, that's huge. That's a big multiplier, right? And you get 224. Now here, this article reference says in accordance with, this article reference right here says in accordance with table 250, a protected device that has a rating or setting not exceeding the value calculated to the values given shall be used. Not exceeding, not exceeding, not exceeding, right? So that's why we would go down in this case from the 224, the 224, and we'd go down to 200 amperes. Okay, and of course that's a standard. Okay, so that one's kind of interesting. Slightly different only because it uses this big multiplier here, instantaneous trip breaker, and people get freaked out. Because it's, a number way up there and they're not used to using those. Okay, let's go on to another question. And this will be the last one we cover for this section. Okay, what would be the maximum standard motor compressor branch circuit, short circuit, and ground fault protected device required for a hermetic, okay, a little different, hermetic refrigerant motor compressor with a nameplate rating of 18 amperes. Okay, let's knock this out. This compressor operates on either, it's interesting, 15 to 20 amperes, or 120, 208, 240 volt single phase branch circuit. Exclude any exceptions. Excluding exceptions. There might be a curveball there, but I don't think so. For the most part, pretty simple. Let's go ahead and find these things. 43062 in our code book. 43062. This is motors, right? Because it is a motor, but it's a hermetic refrigerant motor. So we'll probably go to two different sections here. 43062A first. Let's go there in our code books. 430 Nope, messed that up here. Come on. 430.62 is the one I need. 430.62. Okay. There it is. Okay. And we go to A. And you could just put a box around this thing. That's fine. But what I'd like for you to circle is down in here. The 440 is for these hermetic refrigerant motor compressors, okay? But 440.22, there it is, right there. I'd kind of like for you to circle that or highlight that. That's the section we need to jump to, okay, to get the proper rating, okay? And so if we're going to get the proper rating of the overcurrent protected device, we start here, we jump to this other section here. Let's jump there together now. 440.22. So a little bit of code book hopping here. So just do your best to, keep up. I'm not going real fast, but, I'm moving because we're supposed to have these things tabbed and highlighted and good to go for the class, right? We can't just come here, never seen a code book, right? And if that's the case, well, God bless, and we're going to do the best we can. You can always review the sessions, come to another lecture if need be, call and ask the school any questions you might have. Okay, so 440.22a. Now, if we look in there, we should find 175%. There it is, a protected device having rating not exceeding 175%, right? So you really should highlight that portion right there and circle the 175%. So that's very, very important because we have the nameplate, right? So let's go back and write this in our notes here. As a matter of fact, you might need a new page. Let's take a look at mine. Yep, I need a new page. So I'm just going to clear this thing out and start a new page here. And let's write our article references, and that way we make sure we get them in our notes, okay? Not just highlight our book, but get them in our notes. 430.62a, right? That's the one that led us on over. So we'll draw a little arrow there to 440.22a, all right? And that's the one that gave us the multiplier for, in this case, the overcurrent protected device, OCP, of 175%, right? So if the refrigerant motor, right? Let's write that in there, right? If the refrigerant motor's nameplate right is 18 amperes, that's what it said, right? Let's go back and look at that and make sure we got that right. Yeah, nameplate rating of 18 amps. That's very relevant. That's what's relevant in there, right? And what's also relevant in there is this hermetic refrigerant motor compressor, right? Those are basically, there's a lot of stuff in there in that paragraph almost of a question, but isn't it? Those are the two relevant things, right? So in our notepad, we got to make sure we write that, right? The refrigerant motor nameplate, 18 amps, and then we would simply multiply, right, by 1.75, right? That's what we got from the article reference, right? So 18 amps times 1.75 on our calculator. Should be able to do this pretty easy, right? 18 times 1.75. And in this case, 31. And that's kind of a dumb number, right? So this 31.5 amps is not a standard, right? So let's put that, not a STD, not a standard, right? So we know what we got to do, right? We got to take this on over to get a standard size at table 240.6, right? Table 240.6. So let's go ahead and go there in our code books one last time. Make sure we got this thing down here. Jumping around this thing, we've gotten really good at this, and I'm proud of you guys for hanging in there. This is a lot of material, right? So 31, it's not there, right? So we're stuck. No, we don't get stuck, right? 31 falls in there, so we size up to 35. Size up, right? So let's go ahead and put here in our notes, right? Let's put in our notes, size up 2, and then write in your notes, nice big and bold, right? 35 amperes. Excellent. You guys did very good. Thank you for your time.